Good evening, everyone. I hope all you are doing well. It's my pleasure to introduce our Head of Engineering, Mr. 𝑽𝒊𝒏𝒖, who will be leading today's session on RAG for developers. He began his journey with the company right from its early days, has been a strong pillar in its growth and success. Over the years, he has contributed immensely across multiple domains, working with various technologies and consistently delivering his best in every areas. What truly sets him apart is not just his technical expertise, but also his approachable and friendly nature. He's always ready to support and guide junior developers, making him not only a great leader, but also an inspiring mentor. He's known for his dedication and hardworking attitude, and his passion for his work continues to inspire everyone around him. Now, please join me in welcoming Mr. 𝑽𝒊𝒏𝒖.
Thank you, Shana. Thanks for the good words. I never knew I was this good so far. Yeah, thank you. So, guys, very good afternoon. So, yeah. So, we did a poll on what topic that we should be taking for a technical session. So, many topics came in, and this was voted more. Like, people wanted to know more about RAG. What is RAG? So, I think almost all of you by now you will be using any sort of LLM, right? ChatGPT, Claude, DeepSeek, anything, Grok. Everybody will be using. I mean, I know developers will be using any of these LLMs or models by now. So, what is then RAG? What we need to understand with regard to RAG? So, what is the issue with the existing models that we need another solution to overcome? What is that particular pain point that exists within the LLMs? So that's what we are trying to demystify. So what is an LLM? So almost all of you might have used any sort of LLM, like I said, like any, what can I say, like Claude, ChatGPT, Kimike, or whatnot. There are a lot of LLMs that exist. So LLM is a model that has been trained by ML people, and it has a knowledge base. So it has a knowledge base. It can predict text. Technically, it can only predict the next sequence of the text. So it has been trained on a large corpus of data. So the problem with LLM is that this model can't learn live. So when something happens around it, like for example, the current US-Iran war, the LLMs won't be able to deduce anything out of that. So that is the one issue with LLM. Their learning is limited. They have a knowledge cutoff. So that is one issue with LLM. So when we use LLM, any data that's been trained before this knowledge cutoff date, they might be able to answer on it. But anything after that, they won't be. So that's the issue that we are trying to solve. So what is a large language model? So it can answer questions in natural language. That's one benefit, right? Generative AI that we call. So it can answer in natural language. So as I said, technically it can only predict the next token. So that's the one thing. So this is the one problem that LLMs have. So suppose LLM is trained on 2023 data. Training data is collected in 2023. This LLM training is a humongous process, as you might be knowing. Like that's why the NVIDIA shares are all skyrocketing, right? So they need heavy GPUs to be used. So the training is a very Herculean task as it stands today. It needs a lot of energy. You might have heard, like the new paradigm shift happening is on the energy sector. So yeah, so data centers coming along. So why we need this is to power these LLMs or to train and to run these LLMs, we need a lot of memory and resources. So training is not an easy task. So what can we do in an easy way so that the LLM can augment with our latest data? So that's what I hope to demystify by today's session. So that's it. So retraining is hard. How can we give LLM access to fresh data without retraining it? That's where RAG comes in. So what is RAG? That is retrieval augmented generation. RAG. So, I mean, everybody might be familiar with this term because it's all there in the tech bus, a RAG. If anybody asks, AI, the first thing maybe you will be getting a question will be, do you know RAG? So what is this RAG? In simple terms, RAG gives the LLM a context about the latest knowledge or the fresh knowledge so that it can work on that knowledge, then give back some answers. Okay, that is what RAG does. Retrieval augmented generation. So it finds some most relevant documents from our knowledge base. Then it pushes or it injects that to the LLM input prompt. Using that prompt, LLM generates a response. That response will be grounded to our data. How do we ground that data? It depends upon the prompt that we create. So what is a prompt? A prompt is nothing much but a simple text where we inject these elements, like these things came from our knowledge base. So this is in short, in very basic terms, RAG. So just keep these things 2-3 words in mind. Retrieval augmented generation. Retrieval is getting the relevant documents from the knowledge base and then augmented. Inject those documents into the LLM's prompt as a context, then generation. Then now the LLM can answers or give answers on your data, not just on its own training. Actually, it is the LLM that does all of the heavy lifting. We just give it a better inputs. That's all. We just give the prompt we just enrich the prompt. That's a better way to use it. So let's move on. So what problem does RAG solve? So LLM knows, without RAG, LLM only knows what it was trained on. It cannot access any companies or enterprises internal documentations or any new data that has been surfaced. Then suppose the LLM doesn't get trained too often, it gets stale, may hallucinate. This is one of the issues with LLM. Like it can hallucinate, like it can give incorrect answers for a fact. That I believe you might all came across while you were interacting with any of these models. Again, retraining is not a easy or cheap task. Every retraining needs a lot of energy and resources. So with RAG, what the benefit is that it always retrieves the best answers or latest data, and it can search on your private knowledge base. It's always up to date. So the use case of this RAG is with regard to mostly with enterprise and systems like that. For example, in medical field or legal field, the documents get generated very often, right? But you can't train an LLM to read or understand these documents. But we can feed these documents to a RAG system and have the LLM give back answers on that. So that's the problems So just go through this slide, like I'll just skim through this. So it retrieves latest data before answering, always up to date, grounded answers with real sources. It can trace back to the sources that gave this result. No retraining needed. So I can run a RAG application on my laptop. That's a main benefit of that. If I am supposed to run a LLM or a model training on my laptop, it won't work because my laptop is less powerful. I might need some RTX level GPU sort machine to run those level of applications. But a RAG application is it's a simple augmenting, like LLM augmenting application that can be run with any CPU that just supports Python or JS or Spring, Java or something like that. So what are the steps involved in a RAG? First step is ingestion. Ingestion is we will have some documents that pertaining to our knowledge base. Would be PDF, documentations, anything. We need to convert this into chunks. So we need to convert chunks means it will be broken into small parts. Then it will be broken into small parts and then it will be embedded. So for primary stage is how effectively we can break this, like we can chunk this. So we have a long book, say 5 MB or 10 MB PDF document. We need to chunk it. There are tools that will help us, there are libraries that will help us in chunking. And chunking needs to have some sort of a overlap or sliding window. So what's the benefit of having a sliding window is that so the LLM won't lose the context if it is fed with two chunks, two relative chunks. So the rule of thumb is we usually break it into 256 to 512 tokens and then with a 10% of overlap. So this is not an hard and fast rule. These values we get only after some testing, but still this is the a standard sort of a overlap that usually people keep. Now, once the chunking is done, we need to embed this. Embedding means converting these chunks to a array of a vector of numbers. That's how LLMs understand the relationship between the tokens. So as it is shown here, a cat will have some numbers and kitten will have some numbers. These numerical representation, the converting a string or a token to a numerical representation is called embedding. So when it is converted to this numerical form, the similar words or the semantically similar words will come nearby. So it will be in the closer vector space. So this is the whole idea of LLM. So there are databases that can support, that can embed, or that can ingest these vectors. These are some of them. We'll see a demo with the ChromaDB. Then there are a lot: Pinecone, VB8, Quadrant, Fias, pgvector. pgvector lives within the Postgres database itself. So it will be easy for the Postgres database or the Postgres users to interact with the vector database. How do we choose a vector database? It depends upon the requirements that we have. ChromaDB is a simple, what can I say, in-memory vector database that can persist to disk. Then again, Pinecone, VB8 are all enterprise level players. So if you are going for a production deployment, I would suggest go with Pinecone or pgvector. not using ChromaDB. So it is in this database we store the embeddings, these numbers. Okay. Now, whenever a user queries like what is your refund policy on some document or something like that, the query itself is embedded, like using the embedding model that was shown earlier. These are some embedding models that the LLM providers provide. So we pass in the query or the data through chunks through these embedding models. We get back the numbers. So here is a context injection and prompting. So the prompt template, like whenever a user asks a query, the query itself will be embedded to create a vector. Then that vector is sent to the vector database to retrieve top k of similar chunks from the vector database. So we get a set of chunks that matches our query. Then we build a prompt on that context plus the question. We pass it to LLM. LLM works on that, gives back the answer. So this will be a normal, very simple prompt format. You won't see this prompt in any production system. This is a very simple prompt. So this is a system prompt saying you are a helpful assistant. Answer only using the context below. The context will have the chunks that is retrieved from here. How do we retrieve the chunks? Here the vector database will come to play. The user query will be converted to the vectors, which then will be used to retrieve the chunks. Those chunks will be put as a context in here, then the user question. The prompt is the hardest part to get it right. So it's always hard to get a quality prompt, but still there are some systems or frameworks that can help us in doing those things that can help us in getting good outputs. So these are the things, these are the 3 steps that is involved in a RAG system. So first one is ingestion and chunking. Step 2, embedding. Step 3, context injection and prompting. Now, with that knowledge, there are some pitfalls with the RAG design. So if you are chunking if your chunks are bad chunks, like if there exist gaps between the chunks, the relevant documents that gets retrieved will also be bad. So the context of the information that LLM have to answer the question will be bad. Also, if the LLM knowledge base, the vector database, or that is the knowledge base. The vector database is the knowledge base that we will be maintaining on our end. If that becomes stale, remember we talked about the training data getting stale on an LLM side. Same issue can happen on our end also. Our knowledge base can also become stale. No new documents gets ingested to our knowledge base means our knowledge base becomes stale. So these are the main issues the RAG system still has, but we can try to alleviate or we can try to minimize these issues with right prompting, right ingestion, right chunking. But those, if you ask me what is a right prompt means, honestly, I won't have an answer. It depends upon the business. It depends upon the environment that the RAG system is targeted for. There is no single one rule. Okay, this prompt works like the prompt that I shown in the previous slide. No, this is a very generic prompt. So we need to tune on this. And also, one other thing that always we forget is, as we tune on the prompt will become itself a knowledge base. Like a prompt will become too long. Remember, this prompt has to fit in within the context window of the LLM. So that also, so we need to find a balance between the prompt, chunking, ingestion. It's not an easy task, but it's not a hard task also. So other than this RAG, is there any other option by which we can push a latest data to the LLM? One option already know, like fine tuning. But it is hard to fine tune a big model. But still people are doing fine tuning for small models, like the models that we can embed within devices. But it is a tough task to do the fine tuning. Again, another way is to have web search grounding. You might have seen in your latest, I mean, it wasn't like that when ChatGPT came along or Claude came along. Now you can just ask it, search in the web and tell me the answer, right? So these are the tools that we give the LLM to get with new answers or updated answers. LLM learns these tools and then acts on these tools. One of the latest or key advancements in the area is the MCP, Model Context Protocol. So by this, LLMs can communicate with tools to get data, then work on it. So these are some alternatives that we can use to bypass or circumvent the knowledge cutoff that we have with the LLMs apart from RAG. One of the things is long context models. These long context models are, as of now, some models have very large model context window. So we can easily fit a PDF to that particular model window without any ingestion, without any vector database. We can just push in a PDF, then it can answer questions on that. But those models, those LLMs are very heavy to or hard to maintain also. So how do we choose between fine tuning and RAG? So it is easy to ask, like, why can't we just fine tune with the latest data? As I was saying, it is always hard to fine tune. It is nothing like this undoable thing. We can do it, but it is hard to fine tune. So where do we use the fine tuning? Where do we use the RAG? So you can see in here, it is full retraining, high CPU, GPU time, so no source citations. That is one of the major defects with fine tuning. Data freshness, we need to update everything. So for example, so fine tuning actually defines the personality of the LLM. Okay, who am I? That's what fine tuning implies. So suppose we need to create an LLM that responds on our behalf, say Xminds behalf. The best option will be to fine tune it. So fine tuning actually lays the basement for the personality of the LLM. Now, what does RAG do? Upon this personality, RAG says what you need to respond with. So that's the major difference between a fine-tuned system and a RAG. RAG actually augments the fine-tuned model. So fine-tuned model has a behavior or it has a personality. If you ask Claude, who are you? It will give an answer, right? Similarly, how it is giving the answer is like it is fine-tuned to give that answer. That's also it will have some sort of a response style. So these things are baked into the LLM itself. RAG just augments on that. So use fine tuning to teach how to respond and use RAG to teach what to respond. That's a differential between fine tuning and RAG systems. Now this is one of the another buzzword that we all hear in the AI world, that is MCP. So MCP was released by Anthropic. So MCP is a protocol that LLMs can use. Any LLM can use. So this is an LLM independent sort of a protocol. Any LLM can use to call any tools or pulling any data to interface with the external systems like database, APIs, tools. Lately, the QA people might have lately used the Playwright MCP server. Just to interact, it can integrate that MCP server with Copilot, and the entire QA suite will be running within the Playwright server. Okay, so this is a just basic intro of MCP. MCP itself is a nice topic to learn on, but I just put it here just to know. So MCP, you can write MCP server with the help of libraries. It's a well-defined protocol that developers can use to write MCP servers, and that tool will be compatible with any LLM, provided the LLM can understand MCP. That's all. And almost all LLMs are going that direction also. So, as this is being a dev talk, that is incomplete without discussing what are the libraries that help us in doing this or in developing a RAG system. So these are some common libraries that we usually use. I personally have used LangChain and Llama Index. Haystack, I just skimmed for this talk only. Then RAGAS is for evaluation. Evaluation means it can evaluate the responses sent by the, retrieved from the RAG systems. How good is the response? Then we can evaluate and we can then tune on our prompts. So these are some frameworks that help us on that. So RAGAS, like a unit test, you can just set up with a CA on your RAG system and see. So another Python, why Python? That's another interesting question that people usually ask. Python has been the one Go language that has been existing in this ML world, machine learning world. All the major libraries has written in Python, PyTorch, TensorFlow, Jupyter notebooks. So Python has a huge ML library ecosystem. That's why whenever you hear anything about ML or AI, the language of choice will be Python. Because almost all the libraries that ML has a particular counterpart in Python. And to manage these dependencies, of course, pip is there, but for a developer perspective, I would suggest we start using with UV. UV is the latest dependency manager, a modern dependency manager for Python. It's easy to work with UV. As it says, we need to update ourselves to whatever happening around us, right? So that's why. There is no harm in using people anything else for the dependency management, but UV is the modern, most fast dependency manager as of now. And it has some extra perks also, like tool calling, linting, those things, UV rough, yeah, those things. So then another question also comes to, is there any other, so what if I don't know Python? What are the options for me? Like I know Java, so I know Node.js. So these are the answers. Java, especially Spring Boot, lately has started a great ecosystem around Spring AI. I'm not sure if anybody of here has tried that. Just give it a try. You will be amazed with the features it has. You can just build a rack system in a couple of minutes using Spring AI. It has good vector support, like almost like Python, but it is not Python. Yeah. So at times you will feel like it is hard to find necessary libraries. At times, that's all. Again, LangChain has a port of their Python LangChain, that is LangChain.js. Again, we can use with Node.js. And almost our LLMs, like this LLM providers like OpenAI, Claude, whoever, they always expose an API layer, right? These API layer SDKs, they usually ship for multiple languages. So it is not just limited to Python. AI development or AI, what can I say? The latest AI development is not just limited to Python. If you have an idea to develop a Python AI application, you will find right tools in the language of your choice. So that's it. So that was a quick intro into RAG. So I believe you guys got some idea of what is RAG, what is the necessity of building in the RAG system, what is the knowledge cutoff regarding a LLM, and what is embedding, what are vector databases, what is the scope beyond RAG, like how can we enrich the LLM's knowledge outside the scope of RAG, what are the libraries that can help you with regard to RAG. So that was it. And I hope to show a simple demo of a RAG system that I created using LangChain. Hopefully the demo works. Afterwards, we can have a QA session. So remember the RAG system. What are the steps involved in a RAG system? Okay, let me share my screen. So I'm just showing this slide as of now. Okay. Hope you guys can see my screen. So this is a very basic RAG application, very basic. So I'll be using OpenRouter to communicate with the LLM because I can run an LLM on my local machine. it is hard for me to run the LLM on my local machine. So I have created a basic application. So I'll be using Streamlit to run the application. Streamlit is a one nice framework that we can use to scaffold or demo Python applications. So basic workflow is very simple. Like we just drag and drop some PDF in here, and then we ask questions with regard onto that particular PDF. So let me get some PDF. Yeah. Yeah, here you go. First, we need to ingest the document. It will do the chunking. I'll show you the code in here. This is a log. I mean, I'll push this code to the Git repo, so you guys can also take a look at this. Okay. Upload and split chunks. Okay. And one second. Add to the vector stores. Get the vector store. Vector store to add. It adds to the vector store. That's it. You can just go through. This is the. I mean, I have just splitted the code to various. What can I say? Concern files, so it will be easy for you to use. And I'm using ChromaDB to process the vector database. So now that it has ingested, we can ask some questions like, what is AWS? Hopefully this works. Now, what is AWS? It doesn't find any answer. What is easy? Yeah. This is what, see, what is AWS? It should have given answer. So there is some issue with my prompt or something else that it couldn't find the answer from the document that it ingested. Maybe the question was wrong. What is AWS? EC2. Then another question we can ask is, what is VPC? See, this is the beauty of having an LLM to answer our questions. Like we can just type in natural language. The answers are also in natural language. You won't find this exact answer within the document. This is from these answers as came in. Yeah. These are the chunks that are ingested. From these chunks, we push to the prompt. I'll just show you the prompt also. Here we go. This is the prompt that I used. You are an assistant that answers questions solely on the provided quantity. If the answer cannot be found, say, I cannot find the answer in the provided documents. See? Don't make up information that is not in the context. Then I'll ingest the context in here. Then the question. This is the prompt. The answer will come afterwards. The entire thing is done like this. This is how we do in LangChain. So we pass the questions to the chain, then you get the answer. This is the answer. That answer will be outputted here. So this is a basic demo. We'll also have another demo. Just clear all documents. I have another document in here. I don't know how many of you know, like there is another development happening, cache to cache communication. That is enabling LLMs to communicate with each other. This is one latest development that's happening. That is, two LLMs can communicate within each other. So this information no LLM might have ingested, right? So we can have this ingested with our LLM, with our RAG chain. So let me open that. Okay, let's ask some questions. What was the document about? Yeah, see how the answer was very simple. I mean, hardly if you read through this document, you hardly find this simple answer within this. But this is a very simple answer that LLM gave. New paradigm for richer and faster multi-LLM communication. It uses projects KV cache from source model. So and so, so and so, so and so. Now, remember, whenever there is a question being asked to an LLM, there are two things happening. One is embedding the or vectorizing the question, then calling the LLM itself. If you look in the open router, this is the logs. So I have been using Qwen3 model and OpenAI text embedding for embedding. So this was the latest question that we asked. So it embedded the question. That's one call. Second call is this itself, the question itself with the enriched context. This is how the system works. So hopefully we can ask another question also. What is KV? What is KV cache? I hope everybody can see this. Yeah. So this is the basic this application's workflow. PDF loaded, query processing, answer generation. Three steps. That's all. You can view the logs in here. Query logs. So that's it, guys. So I believe I was able to, I mean, hopefully you understood what is the demo is all about. And hopefully I think I was able to put some insights to what the RAG is. So yeah, I think we can take some questions.
So my question is, in real time, this RAG will be dealing with a bulk of data.
Right.
So when considering the response, accuracy is also very important. The accuracy of the response is very important. And also we need to consider the low latency also. So
True.
how will we manage this high accuracy and low latency at the same time in this RAG?
That's a good question. Actually, it's a hard question also. So that's what. It all depends upon how we do the, first it all depends upon how we do the chunking and how we formulate the prompt. If you're formulating a big prompt with too much wrapping and with too much context, of course, LLM will take some time to process and give back the response. So that's what. We start with small, and as I said, I think I did show that we just try to tokenize with again some 256 512 chunks, and then pull some around 5 to 6 top K related documents, then push it to the context and see how it performs. It's only a trial and error that we can get into a perfect accuracy and what can I say, performant rack system. Of course, it is a hard thing, but still with right chunking strategy, we can attain almost. There is nothing like a perfect world. Yeah.
So we need to increase the number of chunks.
Number of chunks. Not really increase the number of chunks. The chunking strategy, as Anand asked, I mean, it's like how do you chunk? Like it should have nice overlap, not too much overlap. Too much overlap means to duplicate chunks getting into the context. So it shouldn't have that. So what can I say? Like it is all about having the right flavor, getting the right flavor right. So yeah, it depends upon the primary thing that we need to consider is what enterprise, what problem that we are trying to solve. Okay, just because you create a rack system, that's the one false notion that people used to do. For example, that just the current demo that I told that created. What do you think if I uploaded 2 PDFs of entirely different behavior? Like one is AWS, one is cache to cache, one is Iran war, something. I mean, the system doesn't know what is the context of these things. Okay, it just ingests this. Then our responses and our context, our queries will all get haywire. So our system has to be tailored only to ingest the documents or the knowledge that we need the LLM to answer, not on a generic thing. Just because we have this power means that doesn't mean we can just put anything to this PDF chunking thing and get back the answer. Yes, if you are building a generic rack system, you can do that, but that won't help you.
Okay. Good, I got it. Thank you.
Thank you, Devya.
Okay. My question is how MCP and RAG are contributed each other, because RAG is for enriching your prompt with the latest data, and MCP for connecting LLM with external tools or API. Right?
True.
So how they are contributed each other to LLM?
It's like, I mean, you have said the answer also. Like RAG is what to respond with. What is the response the LLM should be given? That is what RAG says. MCP determines what are the integrations that the LLM can do. What are the tool callings that LLM can do? RAG just enriches the LLM context. But MCP goes beyond that. So that's why people are moving towards MCP. MCP can facilitate tool calling APIs, and what else? Reading to the database. So MCP is an action-oriented protocol. RAG is how the LLM will be responding with. That's a simple definition. I mean, difference between MCP and not really difference. That's what the roles of RAG and MCP. MCP is catching up now, so that's it.
Okay,
Sort
both
of just
enrich
to add
LLM
to that.
with different ways, right? Both enrich LLM output with different ways.
Yes.
Yeah.
Different protocols. That's true. RAG is simple to start with. MCP gives more flexibility, I would say.
Okay. Thank you. Eda. That's it.
Okay, so I want to know some more details about the vector store, like how the vector store updated when a latest resource is coming. Like instead of uploading a PDF file, I just given a link to the rack, and someone is updated the link. Then how it will find the source is changed?
That's a good question. Yeah. See, that's the main issue with this sort of tutorial RAG programs. See, as I showed the demo, how did I do the ingestion pipeline? I uploaded it, ran a button, click the button, then everything ran. Then I asked the questions. Technically, when you create a production rack system, this pipeline will be automated. As Arina asked, if suppose you need to read from an URL or something like even if the PDF, say if you are reading from the PDF, you can't expect a person to always upload the PDF to the rack system, right? So obviously it will be residing within S3 repository or something there. There will be a chunking or an ingestion pipeline that is happening that will read from these resources, do the chunking, do the embedding, then write to the vector database. This will be an automated pipeline. Usually in production rack systems, this won't be doing with manual things. So all will be automated.
Okay.
Thank you, Anicheta, for sharing your insights and making the session informative. I truly appreciate your time and effort you put in this, and thank you for clearing all the doubts raised here. And thanks everyone for your time and participation. Wishing everyone a great evening ahead. Thank you.
Thank you, fellows.